Hello, everyone, and welcome to our annual Scripps Research Graduate Program Open House. My name is Dawn Eastmond, and I will be facilitating the first part of the event today. After I give a brief overview of the various PhD programs and joint programs that we have at the institution, I will then turn it over to Shannon Deck, who will moderate a panel of admissions committee members, and they will share their tips for putting together a very strong application to our graduate program. After that, Paulo Garcia will moderate a panel of first-year graduate students who will tell you the critical things that they wish they knew when they were in your shoes. And then we will close with a Q&A. So before we get started with the overview, let's review a few housekeeping items. All participants have been muted and your video has been disabled. Whenever you think of a question, please use the Q&A button located at the bottom of your screen to submit your question. Kristen and Jeremy are in that area, and they will be monitoring the questions and will make sure to answer as many questions as possible throughout today's event. Okay, so here is the overview for today. We'll start off by telling you just a little bit about Scripps Research, what makes us special. Then I'll talk about a few graduate programs, including our PhD program, our joint program with Oxford University, our MD PhD programs, as well as some student outcomes. Then I'll talk a little bit about the admissions process, the application requirements. I'll give you some statistics from our admissions cycle 2 years ago, and then just share with you what our goals are for the upcoming year. And then because of all the requests we received about funding, I'll talk a little bit about costs and scholarships and fellowships that will be available to our new class of students. So let's begin by telling you a little bit about Scripps. So Scripps is one of the largest biomedical research facilities in the country. We do basic clinical and translational research. We study over 40 different diseases, as well as doing basic research in biology, chemistry, neuroscience, immunology. Really a lot of great research is happening at our institution. It consists of over 3,000 employees. There are 150 faculty or PIs. They have their own lab, their own research program, so lots of different faculty for whom you can do your thesis research with. In addition, we have 400 postdocs and 300 plus graduate students at our 2 campuses where we offer the graduate program. We are ranked 1, or we were at the time in 2017, and really remain a huge influencer of research across the globe. This basically states that when you look at research publications in various journals, Scripps is the top research institution that is cited in those journals. So that is a really incredible honor, and we are thankful to have that. In addition to our Scripps Research graduate program, there's also a number of other entities that make up Scripps Research. There's the Translational Institute, where we do population sciences. We study the impact of medication and drugs and prescriptions on patients, as well as Caliber, which is our own little drug-making entity within the institution, as well as a number of core facilities where there is high-end technology that can be used to do your research, including mass spec and NMR and cryo-EM as just a few examples. Now let's talk about our doctoral program. So this program began in 1989, and the really interesting thing about our program is that Scripps Research was founded over almost 100 years ago. We'll be celebrating our centennial next year. We were founded as a research entity, and our graduate program was created about 35 years ago from scratch. And at the time, there were very few institutions that were not founded as an educational entity, but was starting a graduate program. And the way it works is that you actually have to put a student through your courses and everything that is going to be part of your graduate program before you can be accredited by, in our case, WASC. So we started this in 1989, and 4 years later, in 1993, we had a big graduation for one student, where one student walked across the stage at our institution with a bunch of faculty and was allotted for their accomplishments. So later that year, WASC gave us our accreditation, and we have held that accreditation for 30 plus years. And we were just recently reaccredited in 2020 for 10 more years, which is the maximum you can obtain as an institution. So now let's talk a little bit about national rankings. So I mentioned how we are unique in that we were not founded as an educational entity, but we are ranked by U.S. News and World Reports. And here are the rankings listed here. We are 7th in top graduate programs in chemistry. We are 4th in biochemistry, 2nd in organic chemistry, and 9th in biology. And this is really an incredible feat. We've been ranked top 10 since 1999, and we are the only non-educational institution of higher ed that is ranked by U.S. News and World Report. So it's a really, really fantastic honor that we have. So now let me tell you a little bit about what you will learn if you are admitted to our graduate program and decide to come to our graduate program. We have 5 learning outcomes, and they are listed here. They're original research, critical thinking, communication, intellectual curiosity, and professional development. It's really, really critical as a PhD student that you are able to achieve these 5 outcomes. So what is original research? I've summarized it here for you. It's really all about learning how to develop and test a hypothesis. You will learn how to test it. You will learn a series of high-powered scientific tools, how to apply them, how to ensure that you are applying them properly. You will learn ethical behavior, and you will also learn quite a bit about mentoring, how to be mentored as well as how to mentor. The second one is critical thinking. This is really, really important as a PhD in the sciences. You need to learn how to identify an issue, regardless of if that issue is in your current field or if it's something that you plan on learning in the future. How do you identify the issue? How do you think about that issue in terms of the information that is known in the field? How do you set up those hypotheses, as I mentioned earlier? And then how do you get to structuring the evidence that you've been able to obtain so that you can address that particular issue? The third one is communication. It's critically important that you're able to share your science both in written format as well as verbally, not only to scientists in your field, but also to scientists not in your field, also to lay people. You will find that you will have to try to get your research funded. Well, how will you do that? You're going to be talking to people who have money who may or may not be scientists. How do you talk to them? In addition, you'll need to learn how to work in teams. Some of those team members will be in your field and some will not. But in order to be a really successful scientist now, learning how to work in teams, across teams, how to contribute to your area, etc., is critically important. In addition, you'll learn how to write manuscripts. You'll learn how to also present your science. The next one is intellectual curiosity. What does that mean? That means that you have to learn how to be a lifelong learner. You need to learn how to be self-motivated. Science isn't always going to work. So what are you going to do then? You really need to know how to dig deep within yourself and be self-motivated. How do you find that relentless urge to uncover problems and to continue going even when science does not work? And lastly, career and professional development. Not only is it important for you to be able to do these critical outcomes in terms of science, but also transferring them into other areas. These areas will include things like budgeting or negotiating or conflict resolution. There are times when you're not, there may be some issues in your lab or with another scientist that you're working with. How are you going to be able to deal with that situation? So moving on now, let me tell you a little bit about the doctoral program requirements. Generally, it's a 5-year program, even though it takes our students anywhere from 5 to 6 years average to graduate. The program consists of several elements, including coursework. Coursework is one of the first elements that you will engage in the program. And our curriculum is customizable, and I'll talk a little bit more about that in a minute. You will have to take 18 course credits, which works out to be about 6 courses. And these courses can be in any of our various 9 research areas, which I'll talk about in a minute. And you can take these courses. You can take them all as a core, what we call as a letter grade, or you have the opportunity to take 2 of them as pass-fail or as an elective. In your first year, in addition to doing coursework, you'll also be required to do laboratory rotations. These rotations are usually 10 to 12 weeks, and most students do 3 rotations, but you're only required to do 1. So I mentioned a few minutes ago about the customizable curriculum. You'll find this image on our website, and when you click on some of these blue tiles here, it will take you into the details of our courses. We offer 40 different courses that are placed into different tracks, and you can choose to take courses in one track, or you can choose to take courses in mixed tracks. And here I'm giving you an example of a customizable curriculum in immunology. So the student, me in this case, chose to take cell biology, molecular biology, immunology, and papers in immunology and microbial science as my core. As I just explained, that is for a letter grade. And then I've decided to take virology and molecular medicine for an elective. And this is a really great curriculum if you're interested in understanding vaccines, or if you wanted to study microbiology. In addition to this, there are a number of other courses that we have available that you can take, and we've listed some of them here, like cancer biology. If you're more interested in cancer immunology, you may want to take that, or signal transduction, or chemical biology, or structural biology, if you were interested in understanding how the structure of a particular virus impacts its ability to invade a cell. So I've shared with you a little bit about your first year in the program. Let's talk a little bit more about the other program requirements. So in your first year, you're spending about 50% of your time in classes and 50% of your time doing rotations. And then in your second year, when you've decided what lab you want to join for your thesis work, you're really finishing up your coursework and trying to develop your thesis project. Because at the end of your second year, you'll be required to develop an advisory committee, which is made up of 3 to 4 faculty members with similar research expertise to what you are working on, so that you can conduct your qualifying examination. So the qualifying examination at Scripps Research is a combination of a written exam and an oral exam. And it basically is all about your thesis project. So what exactly are you going to be doing for your thesis work? You have to write it up with your specific aims and your approaches. And then you will defend it, you will explain it, and really show why that's the appropriate approach to answer your particular questions to this committee of faculty, which I mentioned. So this, after you pass your qualifying exam, you then become a PhD candidate, and then you will continue to meet with this advisory committee every year for them to evaluate your progress on that thesis project. So that is your advisory committee. They will be with you throughout the program. They'll be there to mentor you, to work with you, and hopefully at the end of it, you'll be able to get letters of recommendation from 2 or 3 of those committee members in addition to your advisor. Then let's talk about your other degree requirements. I mentioned the qualifying exam, also known as the candidacy exam. You also have to take what's called an original research proposal by the end of your 4th year. And this is another research proposal that you'll develop that is outside of your thesis project. That's why we call it original. And basically, similar to the qualifying examination, you have to write it up and then defend it to your advisory committee. And then at the end of this process, when your committee feels that you have accomplished your thesis project and you have really developed as a scientist, you will be ready to defend and write up your dissertation, which is all about everything you've been able to accomplish in your time in graduate school. And hopefully that will also lead to many, many publications. So now let's spend a few minutes talking about our SCAGS Oxford program. This is a 6-year program. You spend 3 years at Oxford and 3 years at Scripps, either in California or in Florida. And this really is an opportunity for you to engage with different training environments. Most students will study the chemistry or the biology at Scripps and then have more of a biochemistry approach at Oxford, but it's really an integrated project where you're looking at different aspects of that project at the 2 institutions. So just really briefly, the program is very flexible. You can either start at Oxford or you can start at Scripps Research. Wherever you start, you follow the program at that institution. So here on the left, I've shown if you start at Oxford, what does that look like? At Oxford, they don't have classes, they have rotations, you begin working on your project, they have professional development requirements, and then you take your candidacy there. And then when you move to Scripps, you follow the program at Scripps, which includes continuing the program, that ORP requirement that I mentioned just a minute ago, and then you defend. And then really it just flip-flops if you start at Scripps Research. We have classes, we have rotations, you begin your project, you take your candidacy, then you move over to Oxford, and then you will continue the project there and defend at Oxford. So moving on now to our MD PhD program. We have an MD PhD program both in California and in Florida. And this is an 8-year program in the format of 2-4-2. So what does that mean? That means that you will start in medical school and do your first 2 years in medical school and take the first part of the boards. Then you will go on to graduate school, whether it's in California or Florida, and spend 4 years working on your PhD. And then you will go back to medical school and finish up the clinical portion of medical school. So while you're in the PhD portion of the program, you will be required to take courses. There's a smaller requirement because some courses from medical school can be transferred into the graduate program. You are required to take 4 courses, and you will do your rotations during the summers of medical school. So now let's talk a little bit about student outcomes. As I mentioned, there are about 380 graduate students between our two campuses. We have over 800 alumni. The majority of our students graduate in 6 years, but sometimes it does take a little bit longer. Most of our students have between 3 and 5 publications before they graduate. And most of the students go on to do postdoctoral work. The others will go into industry. Some will go on to do law, and then there are others who are more entrepreneurial in their work. So let's talk a little bit about student outcomes. I mentioned the time to degree is between 5 and 6 years, closer to 5.3 years. I mentioned the completion rate, and here I'm just sharing with you more details about the postgraduate outcomes. Let's talk a little bit about the admissions process. You're going to get a chance to hear details from the faculty, so I'm not going to go into too many details here, but the application is due December 1st, and it's pretty similar to the standard application. You have a transcript, you have 3 letters of recommendation from faculty who you've done research with or have taken classes with. There are 2 statements, a statement of purpose and a research statement. The GRE is not required. If you apply to the SCAGS Oxford program, there's an additional essay that tells about your experience and potential faculty that you want to work with at Oxford. If you are studying outside of the US or received your degree from outside the US, you are required to submit a TOEFL. There are some exceptions, and you can find that information on the website. And there's no application fee. So there's no need for any waivers or anything. There's no application fee to apply to our program. So just a little bit about the admissions stats from 2022. We had 1,049 applications. In California, we were interviewed both remotely and in person, 170 recruits. We admitted 127 and had a class of 49. In Florida, we interviewed 53 students, admitted 38, and had a class of 14. And here at the bottom, I'm just giving you a little bit more stats, a little bit more demographics on those applications and students. So here I've shared with you our goals for this upcoming year. Very, very similar. We want to bring in a class of 50 to 55 in California and 15 to 20 in Florida. We're going to bring in a couple of SCAGS Oxford students and MD PhD students on each of the campuses. So let's talk a little bit about funding. So here are the costs and the support for our program. All of our students who are accepted to our program, regardless of citizenship, will receive the full package that I'm sharing with you here. So the tuition is covered for you. You receive benefits, medical, dental, vision, and mental health. And you receive a stipend. Twice a month, you will receive a portion of your stipend. The current stipend level is actually, this isn't quite right. There's 42 in Florida and it's 44 in California. So it's a little bit higher than the numbers that are here. And so if you're interested in knowing how the students are funded, again, it's covered by the program the entire time. The first year is covered by the graduate office. And then the second year and beyond, it's covered by your PI, usually through grants or some external funding that they have. If you are lucky enough to receive an external fellowship, whether it is through your home country or through the federal government, NSF, NIH in the United States, you will receive a $10,000 supplement. So we strongly encourage you to apply for external fellowships, and then there is the added bonus of additional funds. So here I'm going to end now with our contact information. It's our website where you can find all the information that I shared with you here. And if you have any other questions, you can always email us at admissions@scripps.edu.